Welcome to this session on grading optimization. It's time to go with grading optimizations. My name is Josh Clausen. I work for MGAEC Technology Partners. We are a subsidiary of D3 Technologies. My role at the company is the Design Technology Manager for Civil Infrastructure, and I also oversee our construction services. My contact info is there at the bottom of the screen. Before we get going, I do like to share a little bit about myself. So about the speaker, again, my name is Josh Clausen. I've been with MGAEC for just over 5 years now. I have 21 years experience with Autodesk products professionally, from production drafting to managing an engineering department as a CAD manager, and then on to working at an Autodesk reseller, MGAEC, for the past 5 years, and really developing some amazing workflows and working with some awesome clients over the last 5 years, and just seeing what can be accomplished, throwing different scenarios out there and providing solutions for those scenarios. I wouldn't call them roadblocks, but just oddball situations. That's what I really enjoy about the work. Also, I'm an avid outdoorsman, huge into hunting, fishing, for basically anything that swims, anything that moves. Just love being outside. A couple housekeeping items before we get into the main presentation. We're using the AirMeet platform, as everyone should be aware of, for the ACEC conference this year. Questions will be monitored throughout the presentation. I will actually be mediating. This is a pre-recorded presentation, so as your questions come in, please use the chat box, and I will do my best to address them as they come in. We will have a open discussion towards the end of the presentation, and then if you could please fill out the surveys for quality feedback for future events. This really helps ACEC cater the different either in-person or virtual conferences to the attendees yourselves. So, before we get into grading optimization, let's just talk a little bit about some historic grading methods. From what I've seen in my experience in working with different clients, is we've got a handful of different ways that people create grading exhibits, utilize grading in their objects. The most rudimentary way is drawing contours with polylines. You don't want to do the work to actually grade out that surface, and you know what you want it to look like in the future, so instead of actually modeling it, you're just utilizing polylines to represent the contours of that design surface. The next method that I've seen used quite often is point-to-point and manual surface manipulation. You're dropping in some known calculated elevations and adding those points to your surface definition, and then either swapping tin edges, adding break lines, to a surface definition to manipulate that surface to get what you would like to see as an outcome. And then we've got feature lines. Feature lines as break lines, utilizing feature lines in sites, linking them together using the feature line style hierarchy to dictate which feature line actually takes precedence over the other feature lines to control that elevation, and then adding those feature lines as break lines to a surface definition. Next is our grading tools, with different grading criteria sets inside of Civil 3D, the grading creation tools, and utilizing those tools for many different grading options, but there can be limitations. Historically, the grading tools have been somewhat unstable. That has improved over the recent releases of Civil 3D. But for the most part, if it takes a little bit of experience in getting used to how to properly use those grading tools and set up your sites, and it can be a little bit confusing. And then a combination of all of the above, and the one I guess I don't mention here is using corridors to actually grade out different items. I've seen that as well. So this is grading optimization. This is a video just to kind of see what it does. What this is, it's not generative design. It's optimized design. You actually go in and set different grading features in your drawing and kick it out to grading optimization. We've got our convergence plot that goes through the different iterations, and you can set it to run 25,000 to 100,000 different iterations of the design. We have different views inside of the grading optimization interface to show where we're violating slopes, where we can look at the tin lines of the surface as it's being built, and you notice that it's being optimized. The longer you let it run, the longer you let it run, the better the result is going to be. So grading optimization, what is it? I just kind of went over that. It is, it's a utility that you add into Civil 3D. It does take an additional install, and we'll go over where to get that. But what is it? How does it work? What do I get from it, and where do I get it from? So what is it? It's an alternative to historic grading methods. It's not generative design, but it's optimization. And then how does it work? So you lay out grading features with basic simple polylines. You draw your boundaries of areas, and we have in our grading objects browser a series of grading objects that we can identify through the use of tagging polylines. And then each of these different items, from a building pad, a pond, retaining walls, so on and so forth, you can set the criteria for each of those individual items, and then you send it out to grading optimization to optimize. So what do you get once you optimize or use grading optimization? So once optimized, you'll get an optimized surface, so a new surface definition that will be brought back into your Civil 3D drawing. You have the options of bringing in a series of feature lines. It will take those polylines that you've created and actually turn those into feature lines with elevation and PVIs and elevation points along those feature lines. And then you also have the option to bring in points. If you set a low point or a high point, it'll create Kobo points that you can bring into your drawing as well. You have the ability to rename and select the style that you want that surface to land on, or you can have the option to update your existing surface. So where do I get it from, or where do I get it? Grading optimization is an additional install for 2022. This is only available in the 2022 version of Civil 3D. Recently there was a 2022.1 update for Civil 3D. Grading optimization is compatible with that release as well. But you will need to go out to your Autodesk account under your manage.autodesk.com website, log in, and look at your available products. If you have the AEC collection, you can expand the AEC collection, and grading optimization is an option to install. Now, grading optimization has had 2 updates to it. We've got 2022, 2022.1, and 2022.2 that just released. The 2022.2 release allows you to do retaining walls, which is a very beneficial thing to do in your typical site grading. So let's take a look at grading optimization. Here I have a surface inside of this drawing, just has a surface definition in it. And just to illustrate kind of how simple grading optimization works, I'm going to go to the Analyze tab of the ribbon, and on the far right of the Analyze tab, after installing grading optimization, you'll get a grading optimization panel. We've got grading objects, and then we've got our object browser, as well as our grading object tools that show up in our tool palette. So if I select the button for grading objects, we get our grading object browser, and these are the different types of items that we can identify, again, just through the use of polylines. And then in our tool palette, this is where we actually identify or select what objects we want to be these various types of grading objects. On this site, I'm just going to draw a simple polyline. And we're going to make kind of a funny shaped pond. I'm going to fillet this polyline, put a 20-foot radius on all of the intersections or vertex intersections. And I'm going to identify this as a pond. So in the tool palette, I have a pond object. So I'm going to select the pond object, and then I'm going to select my polyline that I want to turn into a pond, hit enter to accept my selection. In the pond properties, you can see we have another panel that pops up. I can do a dry pond or I can do a wet pond. The difference being the safety bench criteria that you can populate. So we've got our berm, we've got different dimensions, different slopes that we can identify, and then our permanent pool as well. I'm going to leave these as the defaults, but the one thing I want to show here is we're doing 30,000 our volume is set to 30,000. I'm going to run grading optimization, and then we're going to come back and just change the volume and see what the results are. So I've got my pond set. Next, I need to identify my grading limits. So with grading optimization, if I were to just identify that this is a pond and I run grading optimization, it's going to optimize my entire surface. So by setting grading limits, it allows me to only grade inside those grading limits. I'm going to draw another polyline. Just to identify my grading limits. Come back over to my tool palette and set my grading limits by that polyline. We have some different slopes in here. I'm going to drop this one down to 25% for our max slope, our minimum drainage slope, depth of material. We want this to be a break line in the overall surface definition. Balance, cut, and fill, minimize earthwork, smooth surface. These are just all options. Then I'm going to change the color of this to red. So once I've got that criteria defined, I'm going to go ahead and launch grading optimization. Again, off the Analyze tab of the ribbon, grading optimization panel, we've got Optimize. This is going to launch the grading optimization interface, and we'll see that populate here. Once grading optimization is open, we can kind of take a look at what's going on inside of this interface. We can still access our pond criteria. We can still access our grading limit criteria. Essentially anything that you've identified as a grading object, you can come in and tweak the criteria inside the grading optimization interface. So we can see the entire existing ground surface, we can see our grading limits, and then we can see our pond area. I'm going to pull up the visualization toolbar so we can see what different visualization options that we have. We can throw, cut, and fill. We can see which areas are in violation of our criteria that has been predefined inside the grading objects in Civil 3D. You can view a wireframe. You can view contours. I'm just going to turn this off. Down in the bottom right is the Optimize button. Once I select this button, we'll see these contours start to shift and manipulate and change to abide by the criteria defined in the grading objects. I'm going to go ahead and hit Optimize. And then we have this what's called a convergence plot that comes up. So what's happening is it's going through all these different iterations, and what we're looking for is this line to drop and then become more horizontal. Once it becomes more horizontal, our design has been optimized. And we can see those contours slightly changing here. We'll take a little bit deeper look at this in some more complicated site layouts. I'm going to go ahead and close the convergence plot right now. We seem to have quickly optimized this pond, and again the geometry of the pond has changed slightly, and this is all dictated by the volume and the depth that we had defined. So it's taking that area and assigning the volume for the pond off of the shape that we had identified, and we can see that our cuts and fills are being calculated down at the bottom. This is a rolling number because I have not stopped grading optimization, so total cut, total fill, and we're seeing that information. It's trying to balance it out. Now we can see the fill starting to grow, and so I'm going to go ahead and stop grading optimization. In the bottom right, we have send optimized results. This is going to kick this surface back into Civil 3D, populate a new surface definition in our drawing, as well as if we have items identified that create feature lines or Kogel points, we have the option to throw those into Civil 3D as well. So I've got 4 different feature lines. I've got a surface, and I can create that surface. I'm just going to say PR pond 1, and then the style is going to read what styles are available in our current drawing. I'm just going to go 1 and 5 design, and then say finish, and we'll see that information populate inside of Civil 3D. So we can see what we did with our pond, the contours, the footprint of our pond, as well as the grading limits. Now the geometry of this pond is based on the volume. So it took the footprint and the volume that was specified as 30,000 as what's being contained in the pond that was created. If we were to adjust that, we could re-optimize and get a different result. So I've got a couple other drawings here where they're a bit more complex, to where all of the criteria has already been set in place. We'll go through and explore what that looks like and then optimize those different sites. So next I have a riverbank site, and if we look at the grading objects and what is inside of the grading object browser, we've got a grading pad, so these are different zones, and then we've got a hinge area, we've got our grading limits defined, and then we've got a drain line out here to where we're going to run drainage. So those are the only 3 items that are defined in this particular site. But as we optimize this, we'll see this area completely flatten out where we've got all these different contours, because that is one of our zones that we want to grade. And taking a look at that zone, we can see the various criteria. So our max slope is 5%, our minimum slope is 1%. So we should see a result of a very flat area through here. Let's go ahead and kick this out to grading optimization. And we'll see what happens. I'm going to pull up the convergence plot right away, just so we can see what is happening as I hit optimize. So I'm going to select optimize, and we will watch this convergence plot start to take effect. And we can see that vertical line, and we can see our contours starting to flatten out in that area where we're at a 5% and 1% dictated. By pulling up my visualizations, I'm going to select my areas that are in violation, and we can see those starting to reduce as grading optimization is being allowed to continue to run. I'm going to speed this up. Now we can see as this is continuing to optimize, those violation areas have greatly been reduced, and we would let it run longer to fully eliminate all of those areas of violation. But you can see how much smoother our grading area is and the result. I'm going to go ahead and stop this one. Let's look at a different scenario. I'm going to go ahead and close out of grading optimization and hop into a different drawing. So here's just a simple corner lot. Let's look at the types of objects that have been defined in this particular site. We've got a bunch of different zones. Now each of these zones has a different constraint. So we have a no minimum drainage slope on our green space. We have a max slope of 20%. Getting into our sidewalks, we can see our minimum drain and our max slope. Parking lot, sidewalk parking west, similar sidewalk west, road, parking lot itself, sidewalk south, sidewalk parking north. We also have grading limits defined. And then in this particular one, we have these different drain lines. Now, these drain lines are identified by a polyline, and the direction that you draw that polyline dictates which way that water is going to drain. Once we get into grading optimization, you'll notice the little arrows on the drain lines as to which way we want that water to flow. So let's optimize this site. You can tell just by looking at this that the contours are much flatter. We're in a less relief area, but I'll go ahead and optimize, and then I'm going to open up my convergence plot so you can kind of see what's going on. And here are those arrows I was talking about on those drain lines. I'm going to speed this up so we can see what's happening. And that's probably enough for this example. I'm going to go ahead and hit stop. And I'm going to send this optimized results back to Civil 3D. And we can leave this as contours and triangles. I'm not going to rename the surface. I'm just going to hit finish. But notice we have 26 feature lines coming in with this particular one. And if we select that surface and go into Object Viewer, we can see how we've affected this. So we've got a pretty nice looking grading surface in here. Those curb and gutter lines are nice. Different medians, sidewalks, building pad, green space, things of that nature turn out really well. Another item I would like to compare is the original existing ground. So if we grab that original existing ground, we can see, and I'll just go into Object Viewer on this one as well, to show what we started with, and then you all saw that result. Pretty neat tool. Changes the way that you think about grading. It's putting criteria in first instead of defining. So next we'll look at a hospital site. Now this one is quite complex. We've got various items in here from building pads to parking lots, sidewalks, roadways, ponds. And if I look at my grading objects to see what I've got in here, we've got quite a few different zones defined, different handicap areas, pond outlines, but we do have a detention pond defined with a minimum storage volume of 25,000. We've got different grading limits defined, and then we've got quite a few drain lines defined in here. So let's see what this one does. So I'm going to jump out to grading optimization once again. So you can see our site as it currently sits with our polylines defined as grading objects. And let's go ahead and run that grading optimization. I'm going to select Optimize. And we see the magic begin to happen. Pond is being formed over here. Got a large building pad being flattened out, parking lot areas being defined. We'll zoom in. It's really amazing. You can watch all of this happen. but I'll speed this up as well. And I'm going to go ahead and stop this. We can see that area has been greatly optimized. Quite an amazing tool, but just showing a more complex site and how that optimization can work. I've got one more real quick to show you guys, and then we'll get into the Q&A portion of this. This is a hospital site. Again, let's take a look at what we've got for our different grading objects that have been identified. The storm pond is one that I just keep an eye on this as we optimize it. It's pretty amazing how this tool works. So let's kick it out to grading optimization. And I'm going to just orbit this slightly. So we can kind of watch what's going on. I'm going to pull up the convergence plots and hit optimize. And as you can see, the entire site has been graded out from the existing conditions into providing the pond, the building pad, different drainage lines, parking lot, curbs. Just a really neat tool, something that I definitely encourage all of you to explore. If you have access to subscription-based licensing, you should have access to Civil 3D 2022 and be able to start exploring grading optimization. All right. So in review, grading optimization is available in 2022 Civil 3D as an additional download. You can get that download from your manage.autodesk account, and install it. The 2022.2 release allows for retaining wall objects, which is very beneficial to be able to show those retaining walls. Polylines defined as grading entities, so we are not using feature lines and grading off of feature lines. We are actually utilizing polylines and assigning a grading criteria to those polylines, and then we are running grading optimization off of those polyline entities with the criteria bases assigned to them. You launch grading optimization, run your optimization, and then you can send that information back to your Civil 3D drawing. Another thing I forgot to mention is that you can run multiple iterations of grading optimization. So you can run your grading optimization and send it back to Civil 3D, review those results, and then you can send it back to grading optimization to produce a different surface and a different set of feature lines or Kobo points to compare different design iterations. It's a pretty neat tool. We're going to open this up for questions now, and let's see if we've got anything in there. Matt, I think you've been addressing the questions.